Welcome back for Organic Chemistry Decoded. Today we have a problem where we have bromine addition in water to our alkene. So let's work through that reaction mechanism right now. If you want, you can pause it and work through it on your own and come back. So now remember, this is an addition reaction. So we need to be on the lookout for stereochemistry and regiochemistry. So in Br2, remember the bromine, I'm going to do this in red, is like this. So normally there is an equal distribution of the charge in this area because they're equal. However, when it becomes near an alkene, there's what's called an induced dipole. So you have a delta plus and a delta minus. That's a terrible delta. A delta minus here. And that's because basically the electrons here kind of push these electrons away because similar charges repel. I'm probably not explaining that perfectly right, but that's rough overview what happens. So what happens is our alkene comes and pushes its electrons onto this bromine, and this bond pushes its electrons onto this bromine. We are then left with this product right here, where we have the bromine at this position, and then we formed a carbocation at our tertiary position because that's more stable, and we have Br minus. He's hanging around. Then our bromine, with all his or hers lone pairs, comes and hits this carbocation, forming a three-membered ring intermediate. And this is on a face because it's on a ring, which is kind of fixed. Now, the bromine has a positive charge. Also, this bond right here is pretty weak because you can draw the resonance structure back to this. So this bond is weak and there's some character of carbocation there. So that is primed for a nucleophilic attack. Then what happens is our water molecule comes in and kicks that off. And kicks our bonds back up to the bromine. And because of that, in this scenario, it was facing out. The wedge means the bromine's coming out of the plane of the board at us. So the water molecule has to come in from behind, as if behind the board through to it. So it will push the bromine up towards us, and the OH will be formed behind us. Oof, I forgot to switch over to my pen. Then we have the closest thing to our product, where we have our bromine. And remember, there will be an antimer to this as well because this could have also added on the away face. And where's my pen again? And we have H plus, and then we either have another water molecule or a Br minus come and steal this proton. I'm just for this sake, I'm going to say Br minus. Come and steal this proton. Push that, and we have our product. If you want to get more videos like this, be sure to hit that follow button so you can see all the practice problems and explanations that I post, and send this video to a buddy you're in organic chemistry with.